Okay, these are some just helpful hints for acid bases, practice number 1, starting at example or problem number 6. So you need to be on the second page. Here is problem number 6. So each of the next couple slides are going to talk about 6, 7, 8, 9, and just 6 through 9. 6 through 9 is what this set of notes will talk about, just to give you some hints. So let me switch over to my other program. So here we have, I've just copied and pasted example 6. So it says find the pH and the pOH of solutions with the following H+. Classify each as acidic or basic. So all of these values, A, B, C, and D, these are 4 separate calculations that you'll do. And for each of these 4, you will calculate the pH and the pOH and then tell me if it's acidic or basic. It would be very helpful if, when you tell me if it's acidic or basic, very helpful to you if you can justify how. So what I'm saying to you is that all of these values here represent the H+ concentration. So you are going to have to figure out how to do pH and pOH. I'm going to give you an example not like these 4, but another example here for you to work through. And then you will do these 4 examples on your homework packet. So let's say that I have, we'll just, for purposes of simplicity, we're going to call it, when I get my pen working again here, we're going to call it example E. My goodness, let's try this again. I don't know what this thing is doing, but it is doing something funky. Let me see if I can get it fixed. Okay, as I was trying to explain, I figured out fix my pen here. We're going to pretend like we're doing a 6E. So 6E, let's say I gave you 4.77 times 10 to the negative third. Let's just do that. Okay, so 4.77, these are 2.7. So how you would do this problem is you'd have to show your formulas, and we know that based on this question, this equals H+, because what I'm telling you in this question by stating this piece, that each of these represent the H+. So I could see this being here, I could say H+ equals H+ equals, and H+ equals those values. So if this was your example, right, here's what you would do. You would say that H+ concentration can be found. I'm starting out this the wrong way. Let me try this again. We need to solve for pH. So we know pH is equal to the negative log. So you need to show the basic formula every single time, all 4 of these. So negative log of, in my example, 4.77 times 10 to the negative third. Let me clean this up a bit. And then so we're going to grab our calculators and say 4.77 10 to the negative 3. So that's EX button, or the times 10 button, or the EE button. So EXP button, the EE button, or the times 10 to the N button. And I get a pH of 2.32. So that's the first part, and you can show your work here, or you can put it on another sheet of paper, preferably here, so you have some space going across here on your actual piece of paper. And then I can figure out pOH by saying 14.00 equals pH plus pOH. So then I can say 14, yes, you need to write the generic formula each time. This gets you in a habit of knowing what it is. 2.32 plus pOH. To solve this for pOH, I'm going to take 14 minus, because it's being added and subtracted, 2.32. So pOH is equal to 11.68. You're going to circle this answer. You're going to circle your pH answer. And then you're going to tell me if it's acidic or basic, and then why. So you could say that this is an acid or acidic, and you could say because pH is less than 7. I'm going to use a different color with a little bit thicker marker just so you can see that. This is pH is greater than 7. So this is what you're going to do on your paper for parts A, parts B, part 6C, and part 6D. So you have 4 of these problems that you're going to practice this skill over here that I did with. And you're going to circle your pH, circle your pOH, and then write a statement that tells me it's acidic or basic and why. So I hope you listen to the video so that you can understand all these pieces. Okay, so here is what you should get for answers, but you must show your work as I'm showing here. Again, you must give me the generic formula that you're using or formulas that you're using, and then an answer with work. This is what you should get for all 4 of those pieces. These are your answers you should get for that. Okay, looking at 7, it says calculate H plus and OH minus with the following pH. So then these are all pH. So this is pH equals, pH equals, pH equals, and pH equals. I'm going to do an example here. Let's say you have a pH of 5.39. So here's how you would follow through with this problem. I need to get H plus and OH minus. I know that H plus can be found by taking 10 to the negative pH. That's what the antilog means in your notes. We wrote out the word antilog. This is the antilog, or the opposite function, or sometimes referred to as inverse function. So 10 to the negative 5.39. You're going to hit the second function of the log button. So I'm going to put in 5.39 or negative 5.39, depending on how your calculator makes you put it in. And then I'm going to hit second log, and I'm going to get that in scientific. So either move your decimal or know how to use your calculator. This is going to be equal 4.07, I'm ignoring sig figs, times 10 to the negative 6, big M. And now I need OH minus concentration. So to do that, we have to do one of 2 things to get the other value. We could do pH equals, I keep doing that. We don't want to start with pH equals, I apologize. We want to start with 1400 equals pH plus pOH. We knew that pH in my example, so 14.00 minus 5.39 plus pOH. So this is one method. There's going to be 2 ways you can do this, and you don't have to do both. You just have to do one or the other. So then pOH, what did I do? I took 14 minus 5.39, and I got 8.61. And then I can continue on with this problem. Give me just a moment to try to navigate the program so I can get some more screen here. So then I can say OH minus concentration is equal to 10 to the negative pOH. That's the formula I'm using. So this is going to be 10 to the negative 8.61. So we can do 8.61 negative, or negative 8.61 depending on your calculator, and then second log. So this is going to be 2.45 times 10 to the negative 9th. And now if you look at the top of that's my OH minus concentration. Remember I said there was 2 ways. I was going to show you both ways. So that I've now answered both these questions. I've calculated both of these pieces. Now another way that we could have done this, I'm going to change colors. Okay, another way we could have done this is we could have said 1.0, hold on, that's just too thick. It's going to be too hard to read my messy handwriting. 1.0 times 10 to the negative 14 equals H plus concentration times OH minus concentration. And you are going to do then 1.0 times 10 to the negative 14th. We're going to go back up and grab our OH minus concentration, 407 to the negative 6. I misspoke. This is our H plus concentration here, not our OH minus. This is our H plus concentration, 407 to the negative 6. So I'm going to bring that down and plug it underneath here. Sorry, I already forgot what it was. 4.07 to the negative 6. Okay. It is 4.07 times 10 to the negative 6 times OH minus. So we're going to take 4.07 to the, let's try that again. 1.0 to the 14th negative, divide by 4.07 to the 6th negative, and I get OH minus concentration to be 2.45 times 10 to the negative 9th, which you can see that both of these answers are comparable. I think this ended up rounding to 2.46, and that's just because of where we chunk things off throughout. So close enough. What I care about is the exponent's the same, and it's nearly the same value. So that being off by 0.01 is not a big deal to me. Now, you can see that the blue way was shorter than the red way, but either method would be sufficient and okay to do. I don't care which method you use. If you can do both, the better off you are. So now you are going to do that for these problems, and you should get these answers. For the first part of the slide, Chuck cut off the answers over here. So I'm inserting this video, just literally me telling you that the answers were cut off. Here's the correct answers. So you can see the full example 7. Okay, for question 8, it says solution X has a pH of 11.7 and solution Y has an OH concentration of 4.5 times 10 to the negative 2 molar. So to give you a hint, the first part, which is more basic, question 8A or part 8A is saying the phrasing more basic is asking which solution has a larger OH minus concentration. So you're going to have to take solution X and from the pH of 11.7, figure out the OH minus concentration. And then you will write a statement identifying which one has a larger OH minus concentration. And in your statement, you would explain which solution is more basic based on which one has a larger OH minus concentration between solution X and solution Y. So, please show the work to figure out the two OH concentration values. You have one. You have to figure out the OH concentration value for this one, and then write a statement that explains which one is more basic, and in that statement include the values of solution X OH concentration and solutions Y OH concentration in justifying your answer to part A. For part B, which has the higher pOH, you will need to calculate the pOH of both pieces, showing your work for how you get to the pOH for solution X and how you calculate the pOH for solution Y, and then you'll be able to write a statement that shows which pOH is higher based on the work you show. Here is the answer you should get for these. You will need to do more than these two answers, though. You will need to write statements of justification. All right, let's look at this example here. Very similar to part 8, question 9, or question 8, I should say. Now here, question 9. Solution A has a pH of 12.32. Solution B has a H plus concentration of 3 times that as large as solution A, while solution C has a pH of half of solution A. I want to know what is the H plus for all 3 solutions. So for solution A, you need to use the pH value to get the H plus concentration. Then for solution B, you can figure out the H plus concentration of it because it is 3 times that of A. So whatever you get for A, 3 times that. Then for solution C, you can figure out the H plus concentration of solution C because I tell you that the pH is half of solution A. So if you know pH of C then is equal to half of 12.32, then you'll be able to figure out all 3 of your concentrations. Then I would like you to figure out the pH of solution B and the pH of solution C. Show your work for how you get these. And then you will tell me which classify, solutions A, B, and C as either acidic, basic, or neutral. You can do several things to do that. You could talk about whether the pH is greater than 7 or less than 7 to talk about acidic, basic, or neutral. Look at your notes for that. You can you could compare the H plus versus OH minus concentration to identify, whether something is acidic, basic, or neutral. So to classify these, you're going to classify them and justify. You can justify them as acidic, basic, or neutral. In your justification, you will write a statement that talks about their pH and how from the pH you know if it's acidic, basic, or neutral. Or you could talk about how you can tell if it's acidic, basic, or neutral by comparing H plus versus OH minus concentration. Here's the answers you should get, except for on part D, you should write a statement of justification.